Good evening. In last video lecture of mine, we have seen the introduction about engineering mechanics, the systems of forces, and how to resolve the given system of forces to find the resultant force and the direction of inclination of the resultant. In this video lecture, we are going to see something on how to apply Lami's theorem to solve a real-world case problem. In addition to that, I'm going to give you an introduction about free body diagram. So, how important is free body diagram to find the resultant of a force system that is given in an object, and then how to find the direction of the inclination of the resultant in a real-time case problem, right? So, with this brief introduction, we'll move on to the lecture in this video. So, quickly recalling what is Lami's theorem, it states that each force, it is applicable only for three coplanar concurrent forces. So, each force is proportional to the sine of the angle between other two forces. So, quickly represent it in a diagram. I'm just representing the three forces. So, it is coplanar and this is being also concurrent. As we have seen in the last lecture, all these forces are passing through the same point. So, I name this first force as P, the second force as Q, the third force as R. So, keeping that in mind, I should find the angle between the other two forces. For example, let me choose a different color to give you a different denotation. So, this angle is going to be alpha, this angle is going to be beta, okay. So, this angle is going to be beta and this angle is going to be gamma. So, in that aspect, how to write an equation using Lami's theorem and its statement. So, now we can write the statement for the same. So, each force is equal to each other and then it is proportional to sine of the angle between other two forces. So, let me write this and let me tell you what should be written here. So, now keeping this in mind, so let us go back to the statement once again. So, I have represented all the three forces, the force P, Q and R, and it is proportional to sine of the angle between the other two forces. So, if I want to consider the value for P, I should take the angle which is between Q and R. So, what is the angle between Q and R as you could see from the figure? It is alpha. So, I can write it as P by sine alpha. So, if you could give a try for Q, so it is Q divided by sine of the angle between P and R. So, it is gamma. Okay. So, I should go with the last try for the force R divided by sine of the angle between P and Q, that is beta. So, if I consider the force P, it should be the angle between the other two forces. So, keeping that in mind, so P divided by sine of Q and R, the angle made between is alpha, and going with the force Q, the angle should be between P and R, that is gamma. Going with the last force R, the angle should be between P and Q, that is beta. So, this is how we write a Lami's equation with its statement. So, keeping this in mind, let us solve one problem so that we get the tension in the strings, so that we have some understanding about the concept of Lami's theorem. So, I am going to give you a problem statement like, so there is an electric fixture. So, I am going to consider this as the slab portion. I am going to consider this as the slab portion and this as my wall portion. Alright. So, this is going to be my wall. So, I have two strings in the tension. So, let me keep this string as A, B, the common point as C, and I have an electric fixture, a light fixture, which is being used for illumination. So, now how do I find the tensions in this string and in this string? So, how can I find? So, I can use Lami's theorem. So before which I should teach you a concept of free body diagram, so that the importance of free body diagram will help you to solve this kind of practical problems. So a free body diagram is defined as a sketch that represents the reactions, the weight, and all the other forces that is acting at this point or an object by removing all the support structures. For example, if I want to draw a free body diagram for this structure, I should remove all the support structures like wall, slab, and so on, and then I should draw only the forces that is being considered in this case. So keeping that in mind, let me define the free body diagram once again. It is defined as a sketch that has only the reactions and the weight of the object which is considered for the problem, along with all the other forces acting on it, and we are going to remove all the reactions, supports, and so on. Right? So now, how to draw a free body diagram for this case? So if I want to have a light fixture, say for example, the weight is going to be 50 Newton, and the angle, this is going to be 60 degree from the slab, and this is at an angle of 45 degree. So how am I going to draw the free body diagram? This is the case. So once if I know to draw the free body diagram, then it becomes easy for me to understand or use the concept of either Lamy's theorem to find the forces, or in my previous lecture we have seen about resolution of forces, resolving all the forces in horizontal and vertical direction to find the resultant forces. So I can say either we can use Lamy's theorem or resolution to find the unknown forces, right? So before that, we should draw the free body diagram for this object. So as I said in the definition, it should have the weight. So I am going to take this as the common point. So I am drawing the free body diagram here. So let this be as it is so that you understand the concept of Lamy's theorem to apply the formula, right? So I am going to draw this point. So this is going to be 50 Newton. So I have the weight of the object that is given, that is 50 Newton. Then I have two strings that is being held up to the wall and also to the slab. So I can draw that now. So this is for the wall, slab, I'm sorry, this is for the wall, right? Now, so I can draw the axis so that I can measure the angle between each and every forces, right? So keeping that in mind, I know this angle is going to be 60 degree, and also this angle is given as 45 degree from the figure. So if I write like this, I should find out the angles between the forces. So we would have studied the concept of alternate angles, the corresponding angles. So keeping all these basic knowledges in our mind, so I'm going to find the angle between the forces. So now the angle made between these two is going to be 90 degree, since it is a right angle, and then this is also 90 degree between each and every quadrant. And now the angle made by this tension with respect to the horizontal is going to be 60, because the concept of alternate angles comes into play here. Next, coming to this angle, so this will be 45 degree, right? So once if I know all these angles, I can find the angle made between these two forces as well. So it is 360, the entire stretch, minus one is 90, minus another one is 90, okay, minus, so this is going to be 60, and this is 45. So I get it as 180, 240 and 285. So, or in other words, I can go with this top zone, so that this makes a total angle of 180 minus 45 minus 60. So both I'll be getting the same answer as 75 degree. Here also I'll be getting 75 degree. So the angle that is made here is going to be 75 degree, right? Now let me erase this. Let me erase this. So it's not needed for me. Now I have the forces, the free body diagram. As I said, it has the weight that has been considered, right? And also it has both the tension wires where I have removed the slab section and the wall section, and I'm representing it by means of tension in the cables. So this seems to be TCA and this will be TCB. So the tension in the strings, it will be acting in the direction towards the support always, right? Now if I want to write, just keeping this equation on the side, if I want to write the equation considering Lamy's statement, now I can give a try for that, right? So let me start with the first force. The first force is going to be 50 divided by sine of the angle made between TCA and TCB is going to be 75 degree. Alright, equal to. Now I'll go with the second force, TCA. So it is going to be TCA divided by sine of the angle made between TCB and 50. It is 90 plus 45 is going to be 135 equal to TCB divided by sine of, right, the angle made between TCA and 50, 60 plus 90, it is going to be 150. So now I can do this equation, right? First let me equate this two and find the value of TCA, and then if I equate this and this equation, I can find the value of TCB. By this way, I can find the tension in the cables TCA and also the tension in the cables TCB. So hope you understood how to apply Lamy's theorem to find the tension in the cables by considering or drawing the free body diagram concept, which plays a major role to find the unknown forces.